everyone. In today's video we are going to discuss about cardiac cycle. So in the previous video we have discussed that what are the artericles event. We have discussed about arterial systole and ventricle systole. Okay, so now we are going to start our ventricles events. Okay, and now we are going to discuss that what are ventricle systole and what is ventricle diastole. So let's start the video. And before starting this, I request to you to please subscribe to my channel, like my videos, and also press the bell icon to get the notification of all the videos which I have uploaded. So in the ventricle events, as you can see here, your ventricle events is composed of further two events, which is ventricle systole and ventricle diastole. And your ventricle systole is again composed of isometric contraction and ejection period. So now let's discuss it. First is the isometric contraction period. So isometric contraction period in the cardiac cycle is the first phase of ventricle systole. Okay, now here ventricles is going to contract. The first phase is isometric contraction, and the duration for it is 0.05 seconds. Isometric contraction is the type of muscular contraction characterized by increase in the tension. Okay, because here contraction is done without any change in the length of the muscles. Okay, so isometric, the word iso means, what is mean by iso? The word iso mean same. Okay, and the word metric mean meter is the unit of length. So what it is going to indicate that your length is going to same, but your muscles are undergoing the contraction. So isometric contraction of ventricle muscles can also be called as isovolumetric contraction, means your volume is also going to same. If the length same, then volume is not going to change. Okay, so immediately after the arterial systole, means first your arteries are going to systole and the arterioventricular waves are closed. Okay, after the artery contraction, the blood moves into your ventricles, and the arterioventricular waves, which are tricuspid and bicuspid, they are closed due to increase in the ventricular pressure. Now the seminal neural waves, they are always closed, but now due to ventricles contraction are closed cavity in such a way that there is no change in the volume of the ventricular chamber in the length of the muscle. So never the volume change nor the length change, only the tension increases, only the tension increases. So because of increase in the tension, ventricular musculation during the arteriometric contraction, and the pressure sharply increases sharply inside the ventricles. So अब आप लोगों ने you have to remember that what things are going to happen in the isometric contraction period. So first thing is that in this period your this is isovolumetric, because your volume is going to same, and instead of volume your length is also going to same. Okay, so length भी same, volume भी same, और प्रेशर जो है वो आपका क्या रहेगा, इंक्रीज करेगा, एंड टेंशन इंक्रीज होगी. ओके, सो टेंशन आल्सो इंक्रीजेस. Okay, but the length and volume remain same. So first heart sound, the closure of arterioventricular wave at the beginning of this phase produce the first heart sound. So in this period a first heart sound is also produces. Now what is the significance of this contraction? So significance is given below. During the isometric contraction the ventricles pressure increases, ये बात हमें पता है. When this pressure increases above the pressure in the aorta then and the pulmonary artery, the semilunar wave and the pulmonary artery waves opens. ठीक है, and when they opens the blood move into the aorta and then circulate into the whole wave. So this is responsible for the opening of what, semilunar wave. So this is the main significance of isometric contraction, that it is going to open your semilunar waves which is present in your what, in your aorta and also in your pulmonary artery. So I hope that you will understand this concept. Now we move on to the ejection period. So in the ejection period, during due to the opening of semilunar wave and isotonic contraction of ventricles, now your blood is ejecting out of your ventricles, and then after ejecting out of ventricles, they are moving into your aorta or pulmonary artery. So this period is called as ejection period. So this is the definition of your ejection period. And then there is a duration of this ejection period. Its duration is for 0.22 seconds, and the duration of your isometric contraction is 0.005, and it is 0.022. Okay. So now there is stages in the ejection period. Okay, first is the first stage, second stage. First stage can also be called as rapid ejection period, and second stage can also be called as slow ejection period. So first stage immediately after starts after the opening of seminal wave. This stage is large amount of blood is ejected in both ventricle, lasts for this duration. So you have to remember this duration. Now the second stage, the blood is ejected out slowly as much less for duration of this period is for 0.009 seconds. Okay. So in the second stage, your blood is ejected out with slow and with less force, and in the first phase, your blood is ejected out with a large force. Okay, and the duration of both are given below. The first stage duration is more than the second page. Okay, now there is and systolic volume. Okay, so ventricles are not emptied at the end of ejection period. Okay, they are not completely emptied. Some amount of blood remains in each ventricle. Amount of blood remain in each ventricle at the end of ejection period is called systole volume. So this is the systole volume which remains, and what is its amount? About 60 to 80 ml of your blood remains in your heart. So now there is a ejection fraction. So ejection fraction refers to the fraction or the portion of end diastolic volume that ejected out during the each ventricle during the beat. So ejection fraction is the amount of blood which move out through the ventricles during each blood, and from 130 to 150 ml, about 70 ml is ejected out by the ventricles, and normal ejection fraction is 60 to 70. So how much blood is ejecting out? 70 ml. And what is the ejection fraction? Normally its value is 60 percentage to 65 percentage. Okay, how to determine this ejection fraction? So ejection fraction can be represented by ef. Okay, e and small f. So is the stroke volume divided by end diastolic volume, and it is expressed in percentage. So now let's see here. This is the formula for the measurement of ejection fraction: stroke volume and end diastolic volume. So stroke volume can also be written as end diastolic volume and end systolic volume. Okay, and diastolic and end systolic volume means the volume which calculated at the end of contraction and at the end of relaxation. Okay, so and diastolic volume means the volume which remains after the ending of diastole, and systolic volume means the volume which remain after the contraction. Okay, so now you will put these values in the formula, and then you will calculate your ejection period. So ejection fraction is the measurement of left ventricle function. It's considered as the most important index, and it is going to detect whether your left ventricle is working properly or not. Now the next is the protodiastole. So protodiastole is the first phase of your ventricular diastole. Now your ventricular diastole is going to start. First we discuss ventricular systole. And ventricular systole consists of two parts: isometric contraction and ejection period. Now ventricular diastole start, and the first phase or state of the diastole, ventricular diastole, is your protodiastole. Now protodiastole is can also be called as proto diastole, because it pro means word mean के start, something is going to start, and diastole means वही, ठीक है. तो your ventricular diastole is going to be start. So the duration for this time period is about 0.04 seconds. During the ejection of blood. So now let's discuss what things are going to happen in your protodiastole space. Okay, so in the protodiastole, in the first when we discuss this arterial contraction or arterial diastole, we have see all the blood which is present in your ventricles move into your aorta or your pulmonary artery. Now only small amount of blood is remains in your ventricles. Now, what is going to happen due to ejection of all the blood, the pressure in the aorta as well as in pulmonary artery increases. Okay, but the pressure in your ventricles decreases. Okay, so now due to this increase and decrease, there is no change in the heart during this period, and just the protodiastolic phase indicate that your systolic phase is going to end, and there is a beginning of your diastolic phase. Okay, so now your systolic phase of occur outside of your heart. Okay, so now your heart is going to be relaxed. Okay, so during this whole procedure, second a sound of heart is produced due to the closure of semilunar veins, because when the blood enter into your aorta, the valves first open, then after the blood enters, and then these valves close. Due to this closure, another sound is produced, and the first sound which is produced during the isometric contraction, this sound is lub, and the second sound which produced in protodiastole, this sound is dub. Okay, so therefore the heart sound is as lub dub. Okay, so now this is the first phase. Now we move on to the second phase of this ventricle diastole. Okay, so this is the second phase which is called isometric relaxation period. Now systolic period ends, now there is just relaxation. Okay, so isometric relaxation is a type of muscular relaxation in which decrease in the tension. Now your muscle is going to relax without any change in length is not going to change, therefore we again use the word of isometric. As I have explained to you, iso mean same, metric mean meter means length, so your length is going to be same. And isometric relaxation of ventricular muscle, it can also be called as isovolumetric, because if length is not going to change, then your volume is also remains same. Okay, so during the isometric relaxation period, once again all the valves of the heart are closed. Okay, so they don't open. Okay, now both of the ventricles are relaxed in relaxed state or closed cavity without any change in the volume and length. They have same volume, they have same length, they have no tension in them. They just in the period of relaxation. Okay, and this period is for about 0.08 seconds. Now, what is the significance of this relaxation period? So, during this isometric relaxation period, ventricles pressure decreases. Okay, there is no pressure in them. When the ventricular pressure become less and the pressure in the arteria, then the arterioventricular waves occur, and the fall in the pressure in the ventricles caused by the isometric relaxation responsible for the opening of arterioventricular valves. Now your uh, arterioventricular valves which is present in your between the artery and ventricle, they are going to open in this phase. So always remember, whenever the valves is going to open, there is no production of sound. Okay, whenever these waves undergo the closure process, the sound produce. Okay, so now because your arterioventricular waves are going to open, now there is a rapid filling phase. Okay, when these waves are opened, there is sudden rush of blood from arteria to your ventricles. So again your ventricles is going to be filled with the blood, so therefore this is called rapid filling period. So ventricles is relaxed, but now 70% of filling take place during this place, lasts for 0.11 seconds. So this is the time duration of it. So now the third heart sound is going to be produced, but this third heart sound is going to produce due to rushing of blood into the ventricles. Actually, there is a great rushing when these waves are open, and a great pressure of the blood is going to enter into your ventricles. So due to this high pressure, the third sound is appeared. Okay. So now there is a slow filling phase. First rapid filling phase, then is the slow filling phase, and in this filling phase, what is going to happen after the rush of the blood, the ventricles filling becomes slow. Okay, because at the amount of blood is decreasing. So now this is called a slow filling phase. It is diastasis. Okay, about 20% of fillings occur in this phase. Okay, so 20% is 70% filling in the this rapid phase, 20% filling occur in this phase. This is remains for 0.11 second, this remains for 0.19 second. Duration increases, but blood amount decreases. Last is the last rapid filling phase. So last rapid filling phase occur because of arterial systole. Now your arteries is going to be contraction. After slow filling period, arteries contract and push amount of blood into the ventricles. Now what is going to happen when the arteries first contract? No, first artery is not going to contract. Just due to the opening of valve, all the blood from your artery move down to your ventricle. Now the arteries contract and fill a small amount of blood which remains in the artery and push it into your ventricles. Its percentage about just 10%, 70% in this, 20% in this, and 10% in this. So the ventricle filling take place during this period. The flow of additional amount of blood into the ventricles is due to the arterial contraction. This is called as arterial kick. Now at the last, arteria is going to kick the blood, and which is blood is 10% only. So at the last there is the end diastolic volume. So end diastolic volume is the amount of blood remains in the ventricles at the end of each diastole. It is about 130 to 150 ml per ventricle. तो एक ventricle में 150 130 to 150 ml. So measurement किस तरह कैसे करनी है? It is measured by the same method as the end diastolic method. Okay. So this was all about the arteria and ventricles events which I have explained to you. I hope that you will understand this lecture. Now I should give the revision of you that first we define them, cardiac cycle, that the sequence and coordinated events that take place in the heart during each heartbeat. Okay, the sequence of events that sequence of coordinated events that occur during one heart cycle. Then heartbeat is consist of two phases, systole and diastole. Systole is the contraction and pumping blood into the arteries, and diastole is the relaxation filling process. So now there is arterial event and ventricular event. Arterial event composed of arterial systole and arterial diastole, and the duration of it is given here. Now the ventricles event again composed of ventricle systole, ventricle diastole. If durations are given to you, now ventricle systole composed of isometric contraction and ejection period. Isometric contractions mean muscular contraction. So in this, volume and length remain same, just tension and pressure increases. So what is the cause of this? It is caused due to semilunar valve. Okay, due to semilunar wave, and in this first heart a sound is also produces. Now second thing is that arterial diastole. So in the arterial diastole, what is going to happen? So in the arterial systole, there is a rapid last filling phase. It is also called as pre-systolic phase, and it is moving your blood, 10% of your blood into your ventricles. Okay, so it is going to produce your fourth heart sound. And now arterial diastole means arteries is undergoing the diastolic process, and what is the its duration, you know very well. So at the last we discussed the ventricular events, isometric event and ejection period. Isometric events में क्या है? The same length same volume but the pressure and tension increases. Causes उसकी क्या थी? Yes, very good. Cause due to opening of a semilunar wave. Due to not closure, due to opening of a semilunar wave. After that, we have given another thing, which is ejection period. Ejection period is the period due to which is due to the opening of a semilunar wave. Okay, so and isotonic contraction, now the blood is ejecting out of your ventricles. Okay, so first stage is the rapid extracting phase, in which there is immediately opening of semilunar wave and large amount of blood is going out. Second is the small ejection phase. Then we discuss the ejection fraction and how the formula to discover it. Then we discuss the ventricle diastole. So pre-diastole is the first phase. Nothing is going to happen. It's just a phase which is going to indicate your systolic and your diastolic begins. And due to the systolic pressure, the second sound of heart is going to produce, and the first sound is produced in your isometric contraction. Second period is produced in the pro-diastole. Then there is isometric relaxation, mean length same, volume same, tension decreases, pressure decreases, and it is due to the opening of what, AV. Okay, AV node. And then there is the rapid filling phase. In the rapid filling phase, a whole amount of blood is going to into your ventricles from arteria, and 70% filling take place and third heart sound produced. Then there is slow filling phase, in which 20% of blood is remaining rushes down. Last rapid filling phase is this, in which arteria contract and push 10% of blood into your ventricles. This is called as arterial kick. And I have also explained what is end diastolic volume and end systolic volume. So in the next lecture we will go to discuss intra-arterial pressure. So because video get lengthy, and I cannot explain whole chapter in one video. So this was the part 2 of this video. In the next lecture, in the part 3 of this lecture, we will discuss intra-arterial pressure and what the changes occur during this cardiac cycle. So I hope that you will enjoy this video, you have understand all the concept. So please subscribe to my channel, like my videos, and also press the bell icon to get the notification of all the videos which I have uploaded. Thanks again for watching my videos, for liking me, and take care of yourself. Allah Hafiz.